Hello 11th standard students, this is Bhanupriya. Welcome to 100 Learning Together. So today we are going to see the formula sheet for limits and derivative, that is chapter 12, limits and derivatives. You all know, right? Lots and lots of properties, formula, standard results and all that, right? So we are going to analyze those stuffs. So let's start from limit. So consider a function, for example y equal to f of x. So here f of x be a function of x, right? So if the value of x is equal to a, means f of x takes the indeterminate form. For example, the value of the function which is near to the value a, very near to a, if these values tends to a definite unique number, x tends to a, like that means the unique number is called a limit. Okay, so how we will denote this? Limit x tends to a f of x. Okay, so now there are two cases, that is left hand limit and right hand limit. If the value of the function at a point which are very near to a on the left tends to definite unique number as x tends to a, then the unique number called left hand limit. Similarly for the right hand limit. Okay, so these two limits, left hand and right hand limit, these two limits should be equal, then only we can write it as limit x tends to a. For left hand limit we used to write it as limit x tends to a minus f of x, then this should be equal to limit x tends to a positive, that is right hand limit. So if these two limits equal, both exist, if these two limits exist, then we can write it as limit x tends to a f of x. Then there are some important properties of limits. For example, consider two functions, that is f and g. Then both the limits, that is limit x tends to a f of x and limit x tends to a g of x exist. Then these are the properties we can use, that is limit x tends to a, right? So limit x tends to a, f of x is one function and g of x is another function. So if we add these two functions, the limit is common for these two functions. So we can write it as limit x tends to a f of x plus or minus limit x tends to a g of x. So here limit x tends to a is common for both the terms. And second property is limit x tends to a k times of f of x. For example, scalar k is there, means we can take that k as a, yes, we can write it like this. So k limit x tends to a f of x, we can take it outside. Then limit x tends to a f of x and g of x. If we have the two function in a product, means we can also, here also we can substitute like limit x tends to a for the function f of x and also limit x tends to a for the function g of x. Then it is also satisfied for that division, that is limit x tends to a f of x divided by g of x, means the limit is common for both numerator and denominator. So these are the important limits, properties of limits. And there are some standard results. For example, limit x tends to a x power n minus a power n divided by x minus a, means the value of this limit is n into a power n minus 1. Then as and same for the trigonometric function, that is limit x tends to 0 sin x divided by x, which means the value is 1. Then limit x tends to 0 tan x divided by x, the value of the value is 1. Then the value of limit x tends to 0 a power x minus 1 divided by x, means log a base e. Okay, so limit x tends to 0 e power x minus 1 divided by x, then the value is equal to 1. So these are some standard results. Okay, now coming to derivative. So this is the formula, this is the formula which helps us to find the derivative, right? So that is f dash of x. The formula is limit h tends to 0 f of x plus h minus f of x divided by h is known as a derivative of the function f at x, if and only if, that is the function should exist. Okay, then important properties of derivatives, that is d by d, we used to denote the derivative, that is d divided by dx. Then there are two functions, so as like similar to the limits property. So d by dx into f of x plus g of x, which can be written as d by dx f of x plus d by dx g of x. Similar for the subtraction, and similar for similar for the subtraction, but for product, when the two function is in the product, then we have to derive d by dx of f of x, the first function. We have to find the derivative for the first function, and we have to keep the second function as it is, then plus, put plus, then keep the first function as it is, then we have to derive the second function. So this is the format for the derivative of f of x into g of x. Then we have the derivative f of x divided by g of x, that is equal to whole divided by g of x whole square. The denominator function should square. Then in the numerator, the first function should be, we have to find the derivative of the first function and keep the second function as it is, minus and f of x d by dx of gx. So this is the important properties of derivative, and also there are some standard derivatives, that is derivative of xn is equal to n into x power n minus 1. So these are the differentiation formulas. Differentiation is nothing but finding a derivative, right? So the finding a derivative, one of the method is differentiation. So these are some standard formulas. D by dx x power n, that is x power n formula is n into x power n minus 1. Then derivative of sin x is cos x, derivative of cos x is minus sin x. So these are the some standard derivatives. So I hope you guys understand well. So if you have any doubts, you can comment, and thank you guys. Bye bye.